Okay, today's lesson is the 8th grade lesson 1.3b. The objective for today's lesson is students will solve equations that have no solution, one solution, like we've been doing so far, or an infinite number or many solutions. The standards covered in this lesson are 8EE 7A and B. The book numbers out of the hardcover book, it's pages 21A and B, and out of your practice journal, it's 14A and B. And if you have your practice journal, that's what I would like you to use today. Okay, so we're going to be working with linear equations today that sometimes have no solution or an infinite number of solutions. So far, we have been working with ones that have one solution. Okay, so here's an example of working with equations that have a no solution. So they're going to look very similar to what we've done in the past. Right now I have solved 3 minus 4x equals negative 7 minus 4x. So we're going to start as we have in the past. It's when we get to our final answer that it's going to look a little bit different. Okay, so as I work my way through this problem, I'm still going to work to get x's by themselves on one side. So I like to work x's on the left side, so I'm going to go ahead and get rid of this one. So plus 4x. So on this side of my equal sign, I'm going to say plus 4x. Now you'll notice negative 4 plus 4 would give me 0 x's, so these canceled out because I got 0 x's. Okay, so there's really nothing there. But what's left over now that I've done that is I have a 3, my equal sign, and a negative 7. Can 3 be equal to negative 7? No, that's not a possibility. So this is an example of when you would say there's really no solution to this problem. Okay, and this will come into play later on when we're working with some other processes later in the book that you're going to have to understand when we get a no solution situation. Okay, so let's try another one. Now, keep in mind that as we're working through these problems, you're going to have to still use the skills that we've been working on. So for example, here I have some distributive property. So it's having us practice that distributive property some more. Okay, so as I work through this, I'm going to distribute 0.5 to 10 and then put my x behind it because the x was right behind the 10. If you need to use your calculator, you may. But I just think of half of 10 would be 5x. And then 0.5 times 7, so half of 7 is 3.5, so plus 3.5 equals 5x on this side. Nothing to simplify there. So now, because I'm looking at this, here's my equal sign. I already have the x by itself, the x's by themselves on the right-hand side, so I'm going to go ahead and get rid of this one. So that canceled out, and if I do 5x minus 5x, that gives me 0 x's or nothing. So now I'm left with 3.5 equals, there's nothing over here. There's a 0, there's nothing there. Well, can 3.5 equal 0 or nothing? No, so that would be a no solution. So when we, whoops, I meant to put an S there. So when we end up where we've got our answers that are different on both sides and the x's canceled themselves out, that is a no solution. Okay, so let's try some where we would get an infinite number of solutions. Now, keep in mind as we're working through these in the book, sometimes you're going to have where you've got what you've been working, where you do have a solution to the problem. Okay, so it's just in that final step that you're making that decision. Okay, so I'm going to go ahead and do my distributive property. 4 minus 6 with my x is equal to 4 minus 4 times 1.5 is 6x. Okay, here's my equal sign. I like to work to get the x to the left side, so plus 6x cancels it out. Plus 6x. Oh, once again, it canceled out. Negative 6 plus 6 canceled it out. It gave me 0 x's. Now, here's what I'm left with. I have a 4 equals a 4. So here I ended up, is that a true statement? Yes, it is, but I didn't find out what x equals. So this would be a situation where when we ended up with the same number on both sides, this would be an infinite number of solutions. Okay, I could put an infinite set of numbers in place of 4 in this equation, and it would still be an accurate statement. I could put 8 in place of that. And as I work through the problem, I'm still going to get 8 equals 8. Okay, the x in there is not going to change anything. So here, because we didn't find out what x was, but we have the same number on both sides, that would be considered an infinite solution. Okay, so let's try another one of those. And then I'm going to have you practice a couple. Okay, so working a little more distributive property again. So now I'm going to do white. Okay, so 3 times 4, 12 with our x. 3 times 1, so minus 3, equal sign. And then I already have 12x minus 3. Oops, forgot my x there. Okay, so now I'm going to work to get x's to one side. I like to work them on the left, but you can choose either as long as you're doing the opposite. So minus 12x minus 12x. Remember, we're doing the opposite when we shift to the other side of the equal sign. Okay, so here, 12x minus 12x canceled it out. I got 0 x's here. There's nothing there, so it's really canceled out. So I have negative 3 is equal to negative 3. So once again, I got the same number on both sides. The x had canceled itself out. This would be an infinite solution. We could put an infinite number of numbers in place of where the 3's are in my equation here that I simplified, and it would still be a true statement. So same number, where when our x's have canceled out, is an infinite solution. Okay, so I'm going to have you guys try a couple to give you a chance to kind of check yourself out. Now here's the thing. I want you to remember that as you work through these, sometimes it's not always going to be a no solution or an infinite solution. Sometimes you're still going to get a solution, just like you have in the first 3 lessons of the book. That's not going to change. It's just when you get down to that final step, if you have no x's left over, that's when you're looking at a no solution or an infinite solution. So work your way through these problems. Pause the video, go ahead and work your way through these problems, and then check back with me and see what your final results should have been for these 2 questions. Okay, so you'll notice in number 1, you should have ended up with an infinite number of solutions, because when you worked your way through and got rid of your x's, you ended up with 42 is equal to 42. And on number 2, in this case, I know that it looks like, oh my gosh, if I look at that initial problem, they look like everything's going to cancel out. But here's the thing, when you look at your x's initially, 1 was positive, 1 was negative. They're not going to cancel each other out when they shift to the other side. So don't get too quick. Just because this lesson is introducing no solution versus infinite solution, you still are going to have some problems in there where you're going to get a solution. So don't look really quick and say, oh, they're both 3's, they're going to cancel out. Pay very close attention. Sometimes you will get a solution. Okay, so you're going to go ahead and work through your workbook pages. And once again, those were pages, I think, 14A and B. I'll double check that really quick. Yep, 14A and B. You're going to work through those. And then when you're finished, check back with me and we'll go through and kind of see where you're at. If you need help with number 11 on that practice problem, go ahead and check with me. But it is asking for perimeters. And remember, perimeters is adding together the outsides. Okay, so you'll just set them up as the triangle is equal to the perimeter of the rectangle, and you will work through that problem to decide if it's a no solution, an infinite solution, or if there is a solution.